recording is not getting started. Okay. So in the last session we were discussing about circular queue. We implemented the linear queue. Then we started with the types of queue. It is linear queue, circular queue, priority queue, and double-ended queue. Okay. Then we switched to the next type of queue, that is circular queue. There we have seen what are the drawbacks of a linear queue and how that drawback is overcome into a circular queue, and what is the need of a circular queue. So in that case, if I remind you again, so the biggest disadvantage of a linear queue is that a linear queue has a memory wastage, and when it does have a memory wastage, once you start inserting a data into the linear queue, and this is my front end, this is my rear end, and we start inserting the data, the rear index keeps on moving, and then when we start deleting the data from the front end, so the front end starts moving. So when the front end starts moving, there is a free block of space which has been created due to this delete operation, and that free block of space cannot be used in linear queue. Okay, so because of that we have a memory wastage. The same problem is overcome in circular queue. And what happens in circular queue, instead of moving linearly, what do we do into a linear queue? So both the indices, the rear index and the front index, both indices move in a linear fashion, in a linear queue. So we make this indices to move in a circular fashion. So the moment we start making these indices to move in the circular fashion, the problem of memory wastage of a linear queue can be easily overcome in your circular queue. Okay, and there we have seen that how can we make the indices to move in a linear, how we can make the indices to move in a circular fashion. The simplest approach is to make use of a modulus operator. So the moment we make use of a modulus operator, we make the indices to move circularly instead of a linear movement. What we need to do, when you see a linear queue and a circular queue, and when we understand what's the difference between a linear queue and a circular queue. In linear queue, the indices move linearly, and in a circular queue, the indices move circularly. That's the basic difference. And importantly, that is the only difference which makes all the differences and gives us a new type of a queue called as a circular queue. Okay. Now, once we understand that whenever we are modifying the index, whether it's a rear index or whether it's a front index, that modification shouldn't be linear. Instead, that modification should be circular. Okay. So basically, whenever we are saying plus plus, or whenever we are saying minus minus, or whenever we are testing for the relation between front and rear for a full condition, so at all those instances, we need to move and we need to check in a circular fashion, and that is done with the help of a modulus operator. Otherwise, everything else can be treated same. I repeat, otherwise everything else can be treated same. The way we handle the linear queue, the same way we need to handle the circular queue. Okay, so the structure can remain same. Most of the functions name, their prototypes can remain same. Only we need to take care of the movement of indices and the conditions like full condition and so on. If you take care of these things, and instead of having them move linearly or test linearly, if we move and test them circularly, then done. Your entire program of linear queue can be easily converted into a circular queue. So that's what we are doing over here. If you see, so the structure is still same, exactly same. The way we had it for the linear queue, the same way we have it for circular queue. Then the full condition. This full condition we have already discussed yesterday. that the moment front, your front is just ahead of your rear. So my front equals to rear plus 1. Okay. So there is no space. There is no space between rear and front. There is no space between rear and front. They are moving circularly and there is no space. Okay. If there is a space, if for example this is my rear end and this is my front end, and if there is a space, so it means that your queue is not full. The moment there is no space, it means that the queue is full. Okay. So that's what we need to check. So the moment your front is just ahead of your rear by 1, and that too circularly, so we say that the queue is full. So when my queue of front double equals queue of rear plus 1 mod max circularly. Mod max means circularly, that's all. Mod max means circularly. So rear plus 1 mod max, if this condition is true, then I can safely say that my circular queue is full. There is no space left between the rear and the front index. And nothing can be reused because all slots are occupied. All slots are occupied. There is no space in the array. Okay? And if there is space in between rear and front is not equals to rear plus 1 circularly, so in that case we can safely say that our queue is not full and we can make use of the free slots between the rear index and the front index. Okay. So this is the if full condition for a circular queue. Then if empty condition remains same because the initial values would remain same -1 -1 for both the indices. So if empty remains same. Then the insert function. Now see the differences carefully. These are very small differences and minor differences, and only with these differences your entire linear queue program can be easily converted into circular queue. So the function prototype, function name, everything we are keeping same. Then we are checking for a full condition. If my given queue is full, then I am returning 0 because the insertion cannot be done since your circular queue is full. Else, if that is not the case, then see what we are doing here. Moving circularly, incrementing the rear index circularly. In linear queue, what we did? Plus queue of rear. Okay? Linear increment. But here the increment is not linear. The increment is circular. What is the circular increment? For the first time when rear is -1, initialization, the next value of rear should be 0. The next value of rear should be 1. The next value 2. The next value 3. The next value 4. After 4, if my max is 5, then after 4, my rear should be again 0. Then 1, then 2, then 3, then 4, then again 0. Then 1, then 2, then 3, then 4. Likewise. So it is moving circular. And to have the circular movement, instead of just incrementing it by 1, what we will say? Rear equals to rear plus 1 mod max. That's what we are doing there. Okay. So Q of rear equals to Q of rear plus 1 mod max. So the moment we write mod max, we are ensuring a circular movement. The moment we write mod max, we are ensuring a circular movement. Okay. So instead of simply writing Q of rear equals to Q of rear plus 1, which is something like Q of rear plus plus or plus plus Q of rear, one and the same thing. What we are doing now, Q of rear equals to Q of rear plus 1 mod max. Okay. So we are writing mod max to have it as a circularly moving index. That's all. So Q of rear equals to Q of rear plus 1 mod max. Then Q of data equals to Q of rear equals to D. Q of data, then in square brackets Q of rear equals to D. Inserting the given data into the index position rear into our array data. Then if this is the first insertion, if my Q of front is -1, then set it to 0. Exactly just like a linear Q. Let me show you the linear Q insert function. In the last session we had session 14. So if you see this is my linear Q, and if you see the insert function, see here carefully what we have done. This insert function is exactly similar to that insert function, only the increment of your var index is done in a different way. Here the increment is linear. So inside this statement itself, we are writing plus Q of var. So this is a linear model. Okay. There in a circular Q, what we did, we took that plus Q of var out of this statement. We took it as a different statement, and we are writing Q of var equals to Q of var plus 1 mod max. That's all. Everything else is same as it is. If you see for circular Q, again first checking for a full Q, else Q of var equals to Q of var plus 1 mod max, and then inserting a data, checking for the first insertion. If this is a first insertion, then Q of var equals to 0, return 1, indicating that the insert operation has been done successfully. Done. So only with the one difference in the insert function, your insert function of a linear Q and insert function of a circular Q are exactly same. Apart from that one difference. In linear Q, it is plus Q of var, okay, inside that statement itself. And in circular Q, it is Q of var equals to Q of var plus 1 mod max. Then let's see the delete function. The initialize function would remain same, no doubt about it. Then the delete function. So here inside the delete function itself, I am simply checking for the empty Q. Else we can have a is empty function separately, which we can call over here. Okay, one and the same thing, no issue with that, not a big deal. Then in the else part, see what we are doing. Now in the else part, the deletion is always on the front. Okay, and we are first taking the element which is present at the front position, and then we are checking the same testing which we have done for the linear Q. If this element which we are going to delete is the last element, if this element which we are going to delete or which we have just taken into D, if this element is the last element, so your front and rear both should be pointing to the same element, and in that case, when we delete this element, our Q would become empty. Our Q would become empty. Okay? So that is the check. If Q of front equals Q of rear, we simply say Q of front equals to Q of rear equals to -1. Okay? Else, there in the linear Q, what we did, linear moment of the front index. So Q of front plus. That's what we have written into the linear Q. Now this is a circular Q. What we would be writing, Q of front equals to Q of front plus 1 mod max. That's all. Only this difference. So Q of front equals to Q of front plus 1 mod max. What we did for the linear Q? Q of front plus. So in the linear Q, the moment is linear, Q of front plus. In a circular Q, the moment is circular. Q of front equals to Q of front plus 1 mod max. That mod max is the most important thing. So only with that mod of max or mod max, we are making a linear Q we are converting the linear Q into a circular Q. Okay? So that is the only difference. Everything else is same. Exactly same. Entire function is same. No need to change anything. And we are keeping the function same, we are keeping the program same. So at the end of a day, it becomes quite easier for us also. If I know a program for a linear Q implementation using arrays, and if I know these basic differences, I am already ready with a program for circular queue using arrays. With these few basic differences, if I do these basic differences, my entire program for implementation of a circular queue using array is completely ready. So we are not making any other changes into the program. We are keeping it as similar as possible. We are keeping it as similar as possible. Okay, so that is the only difference. In the insert, the only difference is Q of rare equals to Q of rare plus 1 mod max. In delete, the only difference is Q of run equals to Q of run plus 1 mod max. Insertion is done from the rare end, so the rare index is modified circularly. Deletion is done from the front end, so the front index is modified circularly. Then comes our display function. Now we need to understand the display function and also the search function. Here, the display function for the circular queue and the display function for the linear queue, and even the search function for both the programs would remain same, exactly same. The only difference is what? In display function and also in the linear function of a circular queue, if you see, the for loops are same, or the for statements are same. Okay, what we had for I equals to Q of front, okay, I less than equals to Q of rare, I plus plus. So there we had a linear relationship between front and rare, and the moment was also linear. But now in a circular queue, the moment is circular. The relationship between the front and rear can also be treated as circular. Okay. So the only difference is going to come into this for statement. And this is very important. This is a little tricky, and you need to see it carefully that at any point of time, your front can be ahead of rear, or your rear can be ahead of front, because they are moving circularly. Now, since they are moving circularly, we cannot guarantee that your front would be always behind your rear, or your rear would be always behind your front. Both the possibilities exist. Both the possibilities are there. Okay? Because it is a circular moment. Now, since it is a circular moment, since it is a circular queue, we need to accordingly check for the thing. Now, let's see how we are implementing it. So, if I show you about linear queue, so see here in the display function. This was the for loop. We started from the front and we went up to there and we implemented the index by 1. So, Q of I equals to Q of front, I less than equals to Q of there, I plus plus. But here we cannot do the same thing in circular queue. So, what we did? See the for loop here. We are saying I equals to Q of front because the display should be done from the front end. Okay, the frontmost element of the queue should be displayed, should be processed first. Then the second, then the third, then the fourth, and then the last one. Last one is pointed by the rear index. The last element or the last data point is pointed by the rear index. Okay, so the processing of a queue, the display of a queue should always start from the front index. Okay, and it should go up to the rear index. So what we are doing over here, I equals to Q of front, and then we are not checking for less than or greater than, because as I said your front can be less than rear or your front can be more than rear. It is not assured that the front would be always behind rear or the rear would be always behind front. So in that case, what is a safe condition to test? Not equal to. I repeat, not equal to. Okay. So I not equal to Q of rear. I not equals to Q of rear. So we are starting from the frontmost element. So we are saying I equals to Q of front, and then after that Then after that, we are checking for the condition I not equals to Q of there. We started from front, we need to go to there. So we would say not equals to Q of there because we do not know whether it is less than or it is greater. But we know that it is not equals to. Okay. So we are saying I not equals to Q of there, and then after that see what we are doing. The modification of the index. Now since this is a circular queue, in a linear queue, the modification was linear, I plus plus. But in a circular queue, the modification is expected to be circular. Okay? So that's why what we are writing, I equals to I plus 1 mod max. I equals to I plus 1 mod max. This is the updation of the condition variable. My condition variable is I or my index is I. So I am updating I circular. So instead of simply writing I plus plus or I equals to I plus 1, what we would be writing I equals to I plus 1 mod max. Okay? And that I plus 1 should be obviously into the bracket. So I plus 1 in bracket mod max. Then inside this statement, inside this for loop, we are simply displaying the data element of the array data with an index r. So printf %d /n q of data of r. Okay? Once this is done, then after this for loop, when we come out of a for loop, then we are having one more print statement and the same print statement. Printf %d /n q of data of r. Can someone tell me why do we require this additional print statement outside the for loop? This print statement is outside the for loop. Okay? When the loop terminates, when the loop is done, when the loop is completed. Okay? So can someone tell me why do we have this print statement? What is the use of this print statement? Yes, please. You can answer into the chat box or you can unmute your mic and you can tell me the answer. Yes, please. Yes, please, someone answer me. Why do we have this print statement outside the for loop? Am I audible? So you are answering me or should I pick only one student? Okay. Ansari Salim. Ansari Salim, are you there? Ansari Salim, are you there? Ah. So tell me, why do we have this additional print statement outside the for loop? What if we do not have this print statement, this additional print statement? What would happen? Chalo, fast. It is quite evident from that for statement itself. If you read that for statement carefully, so from that for statement itself, you would come to know that yes, you need addition. Yes, few students are answering, but I need an answer from Sareem. Yes, Sareem, come on, attempt it. can answer into the chat box, or you can unmute your mic and say, come on, fast. Chalo, fast, you are taking everyone's time. Yes, Sareem, print last data. Okay, so he's right. What happens that if you see the for statement carefully, so inside this for statement, the condition is I not equals to Q of R. This is the condition. Now what happens when this condition is false, or when this condition is true, it will keep on getting inside the loop. The moment the condition is false, it means front equals rear, or I equals rear. I started from front, sorry. So I equals rear. The moment I equals rear, the condition is false, so it will come out of a for loop. But when it come out of a for loop, I is equal to rear, it means that the last element, which is pointed by the rear index, that element is not displayed. We need to still display that element. Okay? So that's why after the for loop, or outside the for loop, we have the same statement again. Q of data of I. Now I is pointing to the rear, or I is having the value of rear, so I is pointing to the last data element, and now that last data element would be displayed. Okay? So this is how we will be displaying a circular queue. If you want, then you can come out with some other way also for displaying the circular queue, or all the elements of a circular queue. Okay? Then let's see the search, how the search method is implemented. Now this is our search function. What we are doing into the search function. Same thing, same type of loop for I equals to Q of front, I not equals to Q of rear, I equals to I plus 1 mod max. Okay. Now inside this, we are saying if Q of data of I double equals K, that is the given data, this given data. Okay. If it equals K, then we are returning the index value I. Okay. Just like your linear queue. And then after this for loop, once this for loop is done, so still one element is yet to be compared, and that element is the last element, okay, which is still getting pointed by I. Okay. So after this for loop, again we are making the same check. If Q of data of I equals K, then return I. Okay. So this is the check for the last element. Check for the last element. If the last element equals the given key element, then return I, and the last statement is return minus. यहाँ पर भी हमने return नहीं किया, यहाँ पर भी हमने return नहीं किया. It means that we have searched the entire circular queue, and the given element K is not present or is not found, and that's why we are returning minus 1. There are some queries. Let me read them. So then why don't we put the condition I less than equals to Q of rear? Then we don't require additional things. I tell you, we cannot do that. See, this is a circular queue. Try to understand, when you are moving circularly, there is nothing like this one is ahead and this one is behind. You are moving in a circular fashion, na? So we do not know what do you mean by ahead and what do you mean by behind. Now since you do not know what is ahead and what is behind, you cannot check for less than or greater than. Are you getting it? If you do not know who is ahead and who is behind, then you cannot check for less than or greater than. So in that case, the only possibility is not equals to. Though they are moving circularly, but there would be some point where they may equal. Okay? So till they are not equal, do something. The moment they are equal, then do something else. Okay? Or come out of a loop and do the same thing. And that's what we are doing here. We cannot check for less than or greater than, because this is a circular fashion. Huh? And if something is into the circular movement, how can you say that this is behind this? For example, two things are moving circularly, okay? And in a circular fashion, suppose this point is here, this point is here. How can we say that this point is ahead than this point? Even we can say that this point is ahead of this point, okay? So since this is a circular fashion, we do not know whether it is greater than or whether it is less than. So we cannot put that condition. So the only feasible condition which remains with us is not equals to. If we check for less than or equal to, so it may result into anything. Our loop can become a zero loop, or we do not know exactly. It can turn into an infinite loop, indefinite loop, or it can turn out to be a zero loop. Then to terminate it, we have to put not equals to condition. Yes, true. Okay, yes. Fine. So after that search function, everything else remains same. No difference at all. Your main function is exactly same and can be exactly same to your linear queue main function. So circular queue main function and linear queue main function exactly same, because the signature of all the functions or the prototype of all the functions are same. So you did not have to do anything different over here. Okay, any query from your side? I think we are done with the implementation of a circular queue. Yes, we are done with the implementation of a circular queue. And if there is any query from your side, please ask me. We can discuss on it. The next topic is priority queue and double-ended queue. Priority queue and double-ended queue. There are no programs for priority or double-ended queue. Only we need to understand the concept of the priority queue and the double-ended queue, and the theory about those two types of queue. Then we have some basic applications of queue, and with that we will be completing this module, and then we'll be starting the next module, one of the most important modules of your course, that is linked list. Okay, so one of the most important module, linked list, will be starting after that. So hardly it will take one more session to complete this module, and we hope that tomorrow inshallah we'll be completing this module, and from coming Monday we'll be starting our new module, that is linked list. So any queries into this? And at the same time we are dealing with the lab part. Okay, I would be telling you all the details of the lab, but you need to remember that we are done with the first experiment, which is to create a modular program for performing different operations like factorial, Fibonacci, palindrome, which we have already done. Then the second is the implementation of stack using arrays, done. Then third is the implementation of infix to postfix conversion, that is also done. Then we have implementation of a linear queue, that is also done. And then the implementation of a circular. So this is also done. Okay. So we are already done with 4 to 5 experiments, and I will let you know how to submit your experiment, so you can start submitting your experiment also. Meanwhile, still any query, please come forward. You can unmute your mic and ask a query, or you can put your query into the chat box. You have this one difference in the useful function as compared to linear queue. Then in the insert function, this statement is different. Then in the display function, this condition is different, and also this modification. So for statement is different, and we have this additional print as compared to linear queue. Then the delete, only this statement is different as compared to linear queue. There in the linear queue we had a queue of run plus plus, and here we have queue of run equals to queue of run plus 1 mod max. Then in the search function, just like your display function, your for loop is different, okay? And because of that, we have one more condition check after the for loop for the last element. So that is the difference. Your main function can be exactly same to the main function of your linear queue. So this way you can be in a position to easily attempt or easily write any of these two programs, or even both the programs. And they are important from your theory exam point of view also. Not only from your lab perspective, they are also important from your theory exam point of view. In theory exams also we get this kind of program. Write a program to implement a circular queue using arrays, or write a program to implement a linear queue using arrays. So this possibilities are there. So no queries from your side? Meanwhile, what I do, just a minute. Okay, so still there is no question from your side, so I can now safely assume that you all have understood. And what we will be doing after completing the theory part related to your priority queue and double-ended queue, we'll have a small test. We'll have a small online test to just to see that whatever we are learning so far, whatever we have learned so far, how much we have understood about it. Fine? I'm stopping the recording, and the recording is getting stored into Khan Aftab Alam's Google Drive. So Khan Aftab Alam,